Hello friends, today we're going to continue talking about similar triangles, specifically proportions in similar triangles. We're going to use proportions in triangles to find missing parts. Our state standard, no one apply properties of geometric figures to solve real world and mathematical problems and logically justify results in geometry. So the triangle below was created by dividing one side into 4 congruent segments. So if you look here on the left side, each of these parts is congruent. They all have 1 tick mark. On the right side, each of those parts is also congruent. They have 2 tick marks. So how many similar triangles are in the figure? If you look here, we have this top orange triangle. And then we have 2 triangles. 3 triangles, and 4 triangles. So 4 similar triangles were created when we drew 3 parallel segments. That leads us to this first theorem. You don't need to know the name of the theorem, you just need to know how it works. If a line is parallel to one side of a triangle and intersects the other 2 sides, it divides those sides proportionally. So if you look at our triangle here, we have a short part. Each side has a short part and a longer part. Short part and longer part. So one of the proportions that happens is a short part over the long part of one side equals the short part over the long part of another side. Also, you can do one of the parts either short or long. So either the short part over the whole side or the long part over the whole side. So let's look at some examples. If we look at this question, we need to decide whether we're going to be using short part over long part or part over whole. I need to know if we have 4 different pieces here, 1, 2, 3, 4 different pieces of our proportion. We need to know at least 3 of those 4 pieces in order to solve our proportion. So if I look here, I know that the short part, let's find it again, there we go. The short part on the bottom is 4. And actually we can figure out the long part on the bottom because I know this whole bottom is 14. And if the short part is 4, that means the long part has to be 10. And then on the other side of my triangle, I also know, or I'm looking for the short part, but I know the long part. So I know 3 of the 4 pieces that we need. So we're going to do short part over long part equals short part over long part. I'm going to start with my left side. The short part is x. The long part is 15. On the bottom, the short part is 4 and the long part is 10. So solving this, 10 times x is 10x. 15 times 4 is 60. And if we divide both sides by 10 here, we'll get that x is 6. Let's look at another one, see what pieces we know and what pieces we're looking for. On the left side here, I know the short part and the longer part. On the bottom, I also know the short part, and I'm looking for the longer part. So I know 3 of the 4 pieces for the short parts and the long parts. So setting that up, short part over long part on my left side would be 8 over 20. On the bottom, the short part is 18. The long part is what we're looking for, x. So 8 times x is 8x. 18 times 20 is 360. And then solving this, if I divide both sides by 8, I'll get that x is 45. Let's look at another one. As you see, we're going to be using part over whole on this one, and let's see why. We're looking for x, which is part of the which is part of the whole side. Or x is in the whole side. Here they're telling me that that whole side is 3x minus 3. That's how I know that I'm going to be using part over whole equals part over whole. If we look at the parts that go together, I can see that the 5 and the 10 both go together because they're both sides of this pink triangle. I can see that the whole on the left side is 3x minus 3. The whole on the bottom then, if I add 5 plus 4, the whole is 9. So I'm going to do the part over the whole. On the left side of my triangle, the part is 10. The whole is 3x take away 3. On the bottom, the part is 5. The whole is 9. Now we have to use 5 and not 4. I know 5 and 4 are both parts of the bottom, but because 10 is a side on that triangle, we have to use 5, which is also a side on that triangle. Solving this then, 5 times 3x minus 3. We have to write it like that. Equals 10 times 9 is 90. A little trick here, since the right side only has one term, it just has the 90. I can start right away by getting rid of that 5. I'll divide both sides by 5. So then my left side becomes 3x take away 3. My right side, 90 divided by 5 is 18. Finishing solving this one, we'll add 3 to both sides. So we have 3x is 21. And then dividing both sides by 3, we'll get that x is 7. Let's look at another one here. If I look at my right side here, I know that the whole thing is 12. This little part, or my short part, is 3, which means my long part has to be 9. I see that my x is dealing with the long side on the bottom, or the long part of the bottom side. So I'm going to be doing the part over the whole. If I look at my bottom, the part is 3x plus 6. The whole bottom side is 28. On my right side, the part that I'm dealing with has to be 9 because those are both the longer parts of their sides. 9 and 3x plus 6 are both the longer part of their side of the triangle. And then that whole side is 12. Solving this, 12 times 3x plus 6 equals 9 times 28, which will give us 252. We can use that same trick since there's only one term on this side. I'm going to divide both sides by 12. And I'll get that 3x plus 6 equals, let's see, 21. Then if I take 6 from both sides, I get 3x is 15. And then dividing both sides by 3, we'll get that x is 5. So the trick to these ones is knowing which formula you're going to use. Are you going to use short part over long part equals short part over long part, or part over whole equals part over whole? And really, in order to do that, you need to figure out which pieces you know and which piece you're looking for. Again, if each of these proportions has 4 different pieces, you need to know 3 of those 4 pieces. So you have to look at which 3 pieces you know. The other thing we're going to look at here is a triangle midsegment theorem. Again, you don't need to know the name of the theorem, but you need to know how it works. If a segment joins the midpoint of 2 sides, that means it's in the middle. So here I know that G is in the middle of that side because those 2 sides are congruent. I know H is in the middle of the right side because those 2 parts are congruent. So if that's true, then this middle segment, this is what I'm going to be referring to as middle. This middle segment is half the length of the side it's parallel to. So the 2 formulas we're going to be using is either if we're looking for the middle, then we're going to take the parallel side and divide it by 2. If we're looking for the side of the triangle, we're going to take the middle and multiply by 2. So let's look here. Here they're giving me the length of the middle segment, and they want me to find the length of the parallel side. So I know the middle, I'm looking for the side, which means I'm going to be using side equals 2 times the middle because I'm looking for the side. So WU then equals 2 times 8. So WU is 16. The side equals 2 times the middle. Let's look at another one here. They're giving us the middle. They want us to find the side. So I'm looking for the side, which means I'm going to be using side equals 2 times the middle. So AC is 2 times 4, which means AC is 8. Let's look at some harder ones here because we're dealing with variables. We're dealing with x's for both the middle and the side. Here it doesn't matter because they both have x's. You could use middle equals side divided by 2 or side equals 2 times middle. I think using side equals 2 times middle is easier just because we're not dividing. So here the side is YW equals 2 times the middle is QR. YW is x plus 9 equals 2 times 2x take away 3. We can't use that little trick that I showed you earlier in this lesson meaning we can't just divide by 2 to get rid of that 2 right away because this side has 2 terms. You really only want to do that if there's 1 term on the other side. So we're going to use the distributive property. 2 times 2x is 4x, take away. 2 times 3 is 6. Then I still have x plus 9 on my right side. At this point, there are several ways you can continue to solve this. I'm going to get all my variables on the same side. So take x from both sides. So I'm left with 9 equals 3x, take away 6. And then adding 6 to both sides. 15 equals 3x. And then finally dividing by 3, 5 equals x. If you want to check to make sure you're right, you can always plug it back in for x in both of these expressions. Meaning here, 2 times 5 is 10. Take away 3 is 7. Here, 5 plus 9 is 14. And it is true then that this side is half of the middle, or the middle is this side is 2 times the middle, or the middle is half of the side. That's just if you want to check your work. So here, same thing. I have x's for both my middle and my side. So I'm going to use the side equals 2 times the middle. My side is FD equals 2 times my middle, which is SR. So x plus 2 equals 2 times 2x take away 14. So if I use the distributive property on the right side, 2 times 2x is 4x. Take away 2 times 14 is 28. Again, I'm going to get all my x's on the same side, so I'll take x from both sides. And then I have 2 equals 3x take away 28. And then adding 28 to both sides, I'll get 30 equals 3x. And then finally, dividing by 3, we'll get that x is 10. If you want to check your work, plug x in to your expressions, and our middle should be half the length of our side. 2 times 10 is 20. Take away 14 is 6. And then 10 plus 2 is 12. So our middle is half of our side. We know we did it correctly. All right, friends, that's all I have for you today. Have a good day.